Okay, here's our video, MoonBow, Lunar Rainbow, rainbow from the moon. Has anyone ever seen a rainbow from the moon? It's probably not as clear as you're seeing in this picture. It's a rainbow in the dark, old Dio song. Ronnie James Dio, the late great Ronnie James Dio, wrote a song, Rainbow in the Dark. Just a rainbow in the dark. But that's another video, if I ever make one. But let me get my pen working here. Have that yellow. So most of the time, though, if you ever see one, you might see just a yellow aura around the full moon. And you might see hints of red, maybe not the green, and so forth. But you definitely need moonlight, so we'll say moonlight. Like anything with rainbows, you need light. And if you really want to see a rainbow from the moon, a lunar rainbow, it's best to see a full moon. More light in a full moon. Think about sunlight. Sunlight is 400 times more powerful. Put that X there. More powerful than moonlight. 400 times more powerful. So the rainbow in the dark, again another Dio reference, is not so clear. It's kind of blurry if you ever see one. And sometimes the shape is not so clear if you see a rainbow in the dark. So again, 400 times more powerful is sunlight. And there's a word you should know, it's called lux. And lux is how they measure intensity or luminance, right? So it's the unit to measure light, right? Illuminance. Put that in, illuminance. Fix that eye. So basically the light that's reaching the surface. So if we look at moonlight, moonlight has a lux that equals 0.25. If you want to compare sunlight, sunlight's lux is 10,000. If you want to compare, let's say, a reading lamp, the lux of a reading lamp is about anywhere from 200 to 500. Let's go further. Let's say a stadium. You know, they have the night games. Football, baseball. Let's say Citi Field or Dodger Stadium or anywhere. MetLife. We're looking about up to 2,000 lux. So that gives you a little reference. Yeah, let's change the color. So for a lunar rainbow or a moonbow to happen, obviously it's best to have a full moon. Well, a half moon maybe can do it, but then again the lux goes down. If you want to increase your chance of seeing it, you need a full moon. You also need, so if we make a little box here, what we need a full moon. It's best to have a full moon if we want a rainbow in the dark. And we have to have water. We need water in the atmosphere. We need water droplets. So just after a rainstorm and a full moon. So it's like a prism. You know, when light enters the atmosphere, it will form a prism. And that's why we see the sky is blue and so forth. So there's 3 words we need to know. I'll clear this out in a minute. Well, let's just write it on the bottom. The water, the light's going to enter the water droplets of the raindrops. So we need, it's going to be refraction, which I'll talk about, reflection, and dispersion. Fit it on the bottom here. Go a little slower. There we go. Refraction, reflection, and dispersion. So let's look at those 3. So with refraction, it's just bending of light, refraction. And it gives us an illusion. You may have seen this in science class in high school. Or maybe not. You know, you put a pencil in the water. Let's get water. We have our water here. And when you put in the pencil, when you're seeing it through the glass, it kind of bends. As that, also, the pencil's bending. And that's refraction, because when light enters a medium, like air or water, it will bend. So if we had a water droplet, here's our weird water droplet, and we'll have light coming in. Light will come in, and it will bend. It will bend. So that's refraction. And then when it hits the edge of the water droplet, it will reflect. So let's get a better picture of that, besides my artistic skills there. So here it is. We see, let me make sure my pen's working. See the sunlight entering the droplet, and you see it's refracting, it's bending. So we have this bending, and we have dispersion happening. It's happening here. It's creating a rainbow bridge. And it's going to hit the edge and reflect again. And then when it hits, it will refract. So it's going to refract twice and reflect. Now, sometimes it could reflect twice, but the more it reflects, the dimmer it will be. And of course, this is happening in our atmosphere in the daytime. Blue light will scatter better than any other light. We have blue cones in our eyes. We have red cones also, but red light scatters less. So we see the sky is blue, and I have videos on that if you want to learn about that. But again, we have our prism. It's a raindrop is like a miniature prism. So the light refracts, it bends. The wavelengths of light disperse, as you're seeing. It's going to reflect again and leave the droplet. When it's leaving the droplet, it will refract. Now, there's a special angle that has to happen at, and we'll talk about that. The angles, the geometry. Geometry is important in rainbows. So in the geometry, to see a clear rainbow, even in the dark and light, it should be around 40 to 42 degrees. I'll show you a picture of that. If you're getting anything from 43, let's say 43 to like 52, roughly around that, it gets very dim. And anything greater than 52, you will not see it. And anything less than 40, I should say, you probably will not see it. It's very dim. So the angles are important of how it comes out, and I'll show you a picture of that. So here's the optimal degree. You can see here, 42 degrees to the observer. So again, sun rays come in, we get our prism that's dispersion right here. It's refracting. You see the rainbow. Well, you don't see it yet because it has to reflect once and refract again. And here we are looking at it. There's our vision. And this happens with the moon or moonlight or sunlight. And so if you have angles greater than 42 degrees, it just gets dimmer. It's harder for the viewer on the ground to see it. And when you see a double rainbow, sometimes you see double rainbows. It's very, very rare to see a double moon rainbow. But when you're seeing a double rainbow, there is two reflections happening. But again, the more reflections, the dimmer it gets also. And the angle becomes less than 42 or greater than 42. So again, to sum it up, to see a MoonBow, let's go back to the MoonBow. Here's a picture again, right? So sunlight comes in, and as you can see, it's reflected, it's refracted, dispersed, reflected out, refracted. There's our eyes, and we're seeing it, and you can see, again, the angle, 42 degrees, 42 and a half, 42.5. Within 40 to 42 degrees, you can see that rainbow, and again, with the moon. So to see this rainbow, full moon, and sufficient water droplets in the air.